Hello friends, in this video we will discuss about the given problem, design of a half adder. This problem is from combinational circuits from digital logic design by M. Morris Mano textbook. Here the design means we have to develop the logical circuit diagram with the help of the logic gates. The type of the circuit is half adder. Half adder means it is a combinational circuit which is used to add two bits to produce the outputs as sum and carry. So to design the half adder circuit diagram, we should follow the design procedure. In this design procedure, we have different steps. First, we should specify the definition of the given problem. Half adder means it is a combinational circuit used to add two bits, which provides the outputs as sum and carry. Now, to design this combinational circuit diagram, first we should think about the number of input variables required. The number of input variables required are 2. Those are labeled as X and Y. Why the number of input variables are 2? Because here this circuit is used to add 2 bits only. So for each bit it requires one input variable. Okay, that's why the number of input variables should be 2. Similarly, the number of output variables required are 2 because the circuit produces 2 outputs, sum and carry. Okay, next, with the help of the input variables and output variables, we should develop the truth table. After that, from the truth table, for the output variables, we should obtain the simplified Boolean expressions. And then finally, we should draw the logical circuit diagram with the help of the logic gates. Now, let us develop the truth table. The truth table specifies the number of input variables and the output variables. Here, the number of input variables are 2, X and Y. Output variables are S and C, sum and carry. Now, to write the input variables in binary form, it requires 2 power 2 combinations of binary values because the number of input variables are 2. Therefore, the total number of binary combinations should be 2 power 2. The generalized formula is 2 power n. N means the number of input variables. Okay. So 2 power 2 equal to 4. 0 to 3 only we should take. So first in the truth table in the leftmost column, we should specify the decimal equivalents of 0 to 3. Okay. So now we should write the equivalent binary for these 4 values. So to write the equivalent binary, we should take the binary weights. Okay. So for the input variables, the binary weights should be 2 power 0 and 2 power 1. 2 power 0 means its equivalent value is 1. 2 power 1 means its equivalent value is 2. Okay, based on these two binary weights, we should write the binary values. So for 0, the equivalent binary is 0, 0. For 1, its equivalent value is 0, 1 because to get this equivalent value of 1, the corresponding binary weights should be added. Okay, similarly, to get the 2 value in the position of 2, only we have to place 1. In the position of 1, we have to place 0. Okay, now to get the 3, we have to add these two binary weights, 2 plus 1. In both cases, we have to place 1s. Okay, these are the binary values for input variables. Now we should add these two bits, 0 plus 0. That means the sum is 0, carry should be 0. 0 plus 1 means sum is 1, carry is 0. 1 plus 0 is again sum is 1, carry is 0. 1 plus 1 means sum should be 0 and carry is 1. Because the even number of ones are adding, so that the sum is 0. If odd number of ones are adding, the sum is 1. And the carry specifies the number of pairs of ones. Here 1 means only one single pair is there. So in carry we should write the 1. This is the truth table for half adder. Now we should write the simplified Boolean functions for output variables. So the first output variable is S. Now we should write the S in SOP form. Okay, preferably SOP is better to write the simplified Boolean functions. So to write the SOP, we should consider only ones in the output values. So for 1, the corresponding product of input variables is 0 means complement form. Therefore, this is X bar. Next, 1 means Y, normal form, plus for this one, here 1, 0 means the normal form of X, complement form of Y. Therefore, the equivalent formula is X is exclusive OR with the Y. Similarly, we should write the Boolean expression for carry. Okay. So CSOP, which is equal to here only one single one. Okay. Therefore, for this one, the corresponding input values are 1 and 1. Therefore, the product is x and y, normal form of x and y. Okay. So these two are Boolean functions. Here, no need to use K-maps to get the simplified expressions because these are only two values. Okay. Directly, we can write the simplified expressions. Now, we should develop the circuit diagram. Now to draw the circuit diagram, first we should take the input variables towards the left side. The input variables are x and y. To get the sum output, here x is exclusive OR with y. Therefore, we have to use the exclusive OR gate between these two x and y. Okay. Next, to get the carry output xy. Xy means ANDing operation. Therefore, we should take the AND gate. So for this AND gate, we have to connect two input variables. Okay. So put a node and tick dot, and similarly here also from x we have to connect. So the output is xy, this is a carry. Okay, this is second output. So this is the logic diagram. Hope you understand this concept. If you like my video, please subscribe to my channel DLT Quest. Okay.